Hello friends, myself Dr.Jayvir, and in today's lecture we are going to discuss about Cnc Part Programming. So let's discuss about the programming fundamentals. We have already created the videos for the syllabus topic 1 and syllabus topic 2, and that is also available in this channel. You can refer the playlist which comes at the end of the video in order to sum up with the topic 1 and topic 2. And let's discuss about the CNC part programming, and right now discuss about the programming fundamentals. So machining involves an important aspect of relative movement between cutting tool and workpiece. So in case of computer numerical control, so between cutting tool and workpiece, the motion is controlled by the computer programming. So either the workpiece motion is controlled by computer programming, or say the tool positions are controlled by computer programming. And many cases, as we have already discussed while explaining about the classification of the CNC tools, the 3-axis and 4-axis mechanism, almost in case of 4-axis and 5-axis CNC machine, the workpiece as well as the tool is moving simultaneously. So such kind of programming are governed in case of CNC machine. In machine tools, this accomplished by either moving the tool with respect to workpiece or vice versa. In order to define relative motions of two objects, reference directions are required to be defined. Now, it might be a general question that what do you mean by reference direction and why it is required. So, reference direction means it's something like a benchmark from where the tool can read this is a 0 point. It means whenever we are giving input in terms of programming, that tool needs to move 10 millimeter, 20 millimeter, 30 millimeter, then some 0 reference mark is required, and if such reference mark is available, then from that particular reference mark the tool can move up to 10 millimeter, 20 millimeter respectively. So that is called reference directions. And why it is required? In order to execute programming into automation when there is no human observations are required. This reference directions depends on the type of machine tool and are defined by considering an imaginary coordinate system on the machine tool. So there are many types of origins in case of CNC machine that we are going to deal in a detail in this lecture, but just for your glimpse that machine origin and workpiece origin are two different things which can be differentiated by their names only. So machine origin is something which relates to machine, and workpiece origin is something that which relates to workpiece. Suppose in case of workpiece, if anyone, suppose let's take an example, this is as an workpiece, this is a workpiece. So in this workpiece there are top surface, there is bottom surface, and certain thickness is also there. So it might be possible that we can assume this particular top surface left top corner as an origin, and some other programmer thought about to take this bottommost corner as an origin. So both things can be happen, and such kind of flexibility, such kind of improvisations are also available in the CNC programming. So only the part of programming, only the part of logic is in the hand of the particular human being. Rest all the uh, processes or programming part is automated by using CNC machine. A program defining motion of tool workpiece in the coordinate system, it's called part program. What do you mean by part program? Which gives direction to tool to move in a certain motion, and in some case it gives direction to workpiece to move in a certain coordinates. That is called part program. And also to perform certain functions like rotary function, like material cutting function. Likewise, lathe and milling machines are taken for case study, but other machine tools like CNC grinding. So here the mainly almost for the GTU examination also, the programming ask for the lathe machine and milling machine only, that is restricted area of the BE engineering. But such kind of programming are also available in case of CNC grinding and all the multi-purpose machines like general drilling machines and special purpose drilling machines as well. So in every machine, whenever machine is attached with a computer numerical program, then it is called a CNC machine. But for the BE level up to the GTU level, we can say that it is restricted up to lathe machine and milling machine in detail programming. CNC hobbing, CNC filament welding machine, etc. can also be dealt with in the same manner. So as I already said you, every machine can become CNC machine just by giving programming element into it. Next is reference point. So part programming requires establishment of some reference point. Three reference points are either set by manufacturer or user. This reference point are either set by manufacturer or user can define that particular reference point. As I have already discussed in this lecture, that if suppose this is a workpiece and if I want to define the top surface left topmost corner as an reference point, so that is called user defined reference point. But each and every machine comes with the manufacturer defined machine origin points, so that is called manufacturer defined reference points. So first one is machine origin. The machine origin is a fixed point set by the machine tool builder, it means manufacturer. Usually it cannot be changed. Any tool movement is measured from this point. The controller always remembers tool distance from the machine origin. So machine origin is something from the tool origin. The tool is guided somewhere nearer to the workpiece, and that particular portion from the machine origin where the tool is fixed, and from that point till the part of the workpiece nearer to workpiece, that is called machine origin, and that is set up by the manufacturer and it cannot be changed. Generally it is common for all the machines. Programming origin, it is also called home position of the tool. Program origin is a point from where the tool starts for its motion while executing a program and return back at the end of the cycle. So program origin is generally in majority of the case it is user defined origin. In this case, what will happen if this is a workpiece, then a user can define this particular point as an origin. It is not generally to be. Sometimes user may define the center point as an origin, and sometimes the bottom right point as an origin as well. As you can see, this is a typical example of cubical type of cubical type of workpiece. But if when the shape of the workpiece change, the program origin also gets changed according to the workpiece shape. This can be any point within the workpiece of the tool which is sufficiently away from the part. In case of CNC lathe, it is point where the tool change is carried out. So it is somewhere the point through which the tool change can be carried out. Let's take about the third point, part origin. The part origin can be set at any point inside the machine's electronic read system. Establishing the part origin is also known as zero shift, work shift, floating zero, or datum. So this is particularly a part origin. This is a part origin. It's a datum, it's a 0 point. And somewhere above to it, when the tool is not touching the workpiece, at that point the program origin is mentioned. So program origin is just, if such kind of workpiece is there, then just above the part origin. Usually part origin needs to be defined for each new setup. Zero shifting allows the relocation of the part. Sometimes the part accuracy is affected by the location of the part origin. Figure 1 and figure 2 shows the reference points on the lathe and milling machine. Let's check out this reference point in case of lathe machine. So in case of lathe machine, here it is defines the machine origin, which is very far away from the workpiece. Where is the workpiece? Here is the workpiece. This throughout cylindrical workpiece is attached inside this chuck, which is connected with the spindle. Okay, so this is particularly called machine origin, which is defined by the manufacturer. Now somewhere near to part origin, this is called part origin on the workpiece, and somewhere in between the part origin and machine origin, but generally it is very nearer to part origin. Which one? Program origin is very nearer to part origin but very much away from the मशीन ओरिजिन. यहां से अवे दूर होता है और यहां से नजदीक नियरर. Why it is so? Because the function of the program in origin is to change the tool. In order to change the tool, program origin is required. And why we want to change the tool? We want to perform different operations out of it. So while performing the different operation, whenever we required some different kind of operation, so what we are doing, we are just shifting the tool from the part origin and change the tool and again perform the function on the workpiece. So part origin is very nearer to, sorry, program origin is very near to part origin but away from the machine origin. Setting up of origin. In case of CNC machine tool, rotation of this reference axis is not possible. Origin can be set by selecting three reference planes X, Y and Z. Every CNC machine will come up with their maximum capacity, and their maximum capacity in case of CNC milling machine, which is defined by the movement in X direction, movement in Y direction and movement in Z direction. So this particular movements in X, Y and Z direction limits the CNC milling machine and their functions as well. So that is what written here. The CNC machine, the origin can be set up to certain distance based on their capacity. Planes can be set by touching tool on the surfaces of the workpiece and setting the surface as x is equals to x, y is equals to y and z is equals to z. ये जब तक आप काम नहीं करोगे CNC मशीन पे तब तक समझ में नहीं आएगा, फिर भी मैं आपको समझाने की कोशिश करता हूँ कि अगर आपके पास CNC मशीन है, सो व्हाट यू नीड टू डू फर्स्ट, दैट इज जो भी उसकी वर्कपीस रखने की प्लेट है, वर्कपीस जहाँ पर आप रखेंगे वो जो प्लेट है वो प्लेट एक्स एंड वाई डायरेक्शन में मूव कर सकती है, और जितनी भी कैपेसिटी है मशीन की वो कैपेसिटी मीन्स कैपेसिटी इन टर्म्स ऑफ कि एक्स डायरेक्शन में वो कितना मूवमेंट कर सकता है. सपोज मेरे पास जो 3D प्रिंटर मशीन है वो एक्स डायरेक्शन में 250 मिलीमीटर तक मूवमेंट कर सकता है, वाई डायरेक्शन में भी 250 मिलीमीटर तक मूवमेंट कर सकता है, जेड डायरेक्शन में 20 मिलीमीटर तक, सॉरी 20 सेंटीमीटर, ऑल द डायरेक्शन डायमेंशंस आर इन सेंटीमीटर तक मूवमेंट कर सकता है. तो वहां पर क्या है कि एक्स को लिमिट करने के लिए एक स्विच दी गई है, दैट इज कॉल्ड स्टॉप स्विच. तो जैसे ही स्लाइड एक्स डायरेक्शन में मूवमेंट करेगी तो वहां पर एक पॉइंट पे आके वो स्टॉप स्विच को कनेक्ट करेगी, सो दैट इज कॉल्ड एक्स डायरेक्शन स्टॉप स्विच. वैसे ही अगर स्लाइड वाई डायरेक्शन में जाके कहीं पर स्टॉप कर रही है, सो दैट इज कॉल्ड वाई डायरेक्शन स्टॉप स्विच. एंड ऑल्सो देयर इज वन अनदर पॉइंट दैट इज कॉल्ड जेड डायरेक्शन स्टॉप स्विच. अब जो ये टूल है, सपोज समझ लीजिए कि मैंने एक्स डायरेक्शन एंड वाई डायरेक्शन सेट कर लिए, एक्स डायरेक्शन एंड वाई डायरेक्शन मैंने सेट कर लिया, बट फिर भी अभी भी चांसेस है ना कि मेरी जो सरफेस है वो ऐसे टिल्टेड रहे, ऐसी टिल्टेड ना रहे तो ऐसी टिल्टेड रहे, चांसेस है. तो ये जो पैरेलल है या नहीं है उसको चेक करने के लिए आपको क्या करना होगा, पहले आपको पैरेलल करनी होगी इस प्लेट को. किस तरीके से करेंगे, तो इसके नीचे छोटे छोटे स्क्रू लगाए गए होते हैं एडजस्टेबल. तो उसको हम क्या करते हैं कि बार बार या तो हम इस सरफेस को ऊपर कर सकते हैं या तो नीचे कर सकते हैं, और हम टूल को सभी जगह पर टच करवाते हैं. जैसे कि यहां पर टच करवाया, फिर हम उसी टूल को खिसका कर लेके जाते हैं आगे तक, यहां पर टच करवाया, फिर उसी टूल को पीछे लेके आते हैं, यहां पर टच करवाया, फिर उसी टूल को यहां पर लेके आते हैं, यहां पर टच करवाया. ऐसे हम 2-3 बार टच करवाते हैं तब जाके CNC मशीन की जो जेड एक्सिस है ना, जो सरफेस है ना, वो पैरेलल होती है. आपको मैं ये प्रैक्टिकल करके भी बताऊंगा, जस्ट आपके एक्सप्लेनेशन के लिए अभी कि सेटअप कैसे करना है CNC मशीन को, ये पता होना चाहिए. व्हेन यू आर लर्निंग दिस सब्जेक्ट एंड इफ यू आर नॉट नोइंग हाउ टू सेट अप द CNC मशीन, दैट विल बी वेरी डिफिकल्ट फॉर यू टू be employee in any CNC company. Coding system. The programmer and the operator must use coding system to represent information which the controller can interpret it and execute. A frequently based coding system is the binary coded decimal or BCD system. The system is also known as the EIA code set because it was developed by Electronics Industries Association. The newer coding system is ASCII and it has become the ISO code set because of the wide acceptance. So now whatever coding system that we are going to learn in this particular chem subject, that is based on binary coded system, one binary coded decimal system. Again, it is also widely known as EIA code system, where EIA means Electronics Industries Association, and that also approved by ASCII. This is also pronounced as ASCII, ASCII, and ISO code has become ISO code, means Indian Standard Organized Code. So this particular code system is applicable everywhere whenever the CNC machine is employed for that particular manufacturing company. I hope from this explanation you might be you have created your interest towards learning this CNC programming, and in the next lecture, in the subsequent lectures, we will also going to discuss about how CNC programming is working. So stay tuned with this channel, stay tuned with this video, and don't forget to write down your comment in the comment section if you are not getting it something, so that I can also get the glimpse that in which direction I need to improve my lecture. Thank you very much once again, and have a nice day.